All right, well, we'll get started. I think people will continue to join us, and we're also recording the session. So for those that are joining us later or watching a re-recording of it, so thank you for joining us. So my name's Asha Stabak. I'm the Business Development Manager for the Australian Space Data Analysis Facility. We are funded by the Australian Space Agency, as well as the WA government GITSI. So thank you to both of those that have enabling us to create greater accessibility to space data and how we can actually use that. So people think about, the satellites that are being launched, almost on a daily basis, but really around the space data utilization is what we can do with that data and how we can learn how to, protect our planet, and get insights that can actually help us with those decisions as well. So really exciting to be hosting the first in this series. But before I kick off, I'd like to acknowledge and pay my respects to the land on which we meet, the traditional owners. For myself, I'm on the land of the Noongar Nation with the Whadjuk country. But I know that we've got people joining us from across Australia, and pay my respects to all those elders past, present and emerging. So thank you so much to AWS for kicking off this series. We've got Manny and Jasminda, who I'll hand over to shortly. And I'm really excited to see how we can sort of be making the most of these different data sets and learning from the Earth. I would encourage everyone to pop questions in as we go, and we'll be facilitating a bit of a Q&A at the end. And as I mentioned, this will be recorded, so we'll be making this accessible through our YouTube channel and sharing it on our social media platforms a little bit later. And would encourage anyone to reach out at any time if they're wanting to learn a little bit more. So without further ado, I will hand over to AWS, and thank you so much for providing this information to our audience.
Thank you, Asha. It's wonderful to be here. Thank you, everyone, for taking the time out of your day to come in and listen and learn a little bit about what we have on offer for the space and satellite community. We've designed this session, so Jazz and I have designed this session to be purely informational. You will come across a lot of material which will probably require more of a deep dive, but the intent of our session today is literally to enable you and help you understand what tools, assets, collateral, and learnings we have from supporting the space industry. Amazon has been doing this for a very long time. And literally what we want to do is share some of the learnings that we have, help you understand what we've done in different parts of the world for different kinds of space customers at different stages of maturity, and see what we can bring to bear for the Australian community of builders. So Jazz and I will probably do this very informally. We'll talk to a couple of slides together. There's some that I'll do, some that he'll do. If at any stage you have questions, like Asha said, please feel free to lock them in, and we will have plenty of time towards the end for a dedicated Q&A session. So without any further ado, let's jump in. Jazz, first slide. We want to level set for you. So we'll begin with what is AWS, and I'm sure a lot of you have come across AWS Cloud or cloud technologies in general, but it's literally service on demand. Now we have over 200 services, abstract services, everything from basic compute and storage and security, all the way through to some of the more newer services, machine learning, robotics, high performance computing, ground station communications, all of which lend themselves, particularly the abstract services, really lend themselves well to the community of space builders, space and satellites segments. So we'll spend some time talking about what some of these services are and how we stitch them together to form solutions which then accelerate your space missions. What sets AWS apart from other cloud providers, vendors? Next slide, please, Jazz. It's literally our attention to what you see on the slide: security, job zero for us. A lot of space, you know that all space started with a lot of government organizations, entities which have a high predication with security. So we've designed from day one with security in mind. NASA, for instance, NASA JPL is one of our earliest customers. But as we go through several more examples later in the session, you'll understand how security, particularly when it comes to space domain awareness and many of the other workloads or the mission-specific details, where this comes in really handy. I've said a little bit about the depth and breadth of the services that we have. Jazz, as a solution architect, spends a lot of time on these services. I myself haven't had a chance to actually get into any level of depth because there's so many. The relevant piece is what we're going to focus on today, but this is a discipline in itself, the software solution architect, etc. So we'll spend some time on the learning profiles and pathways that you may want to take up if you decide to build natively on cloud. Other reasons why cloud is relevant to us in this conversation, particularly around space and space builds. Services like machine learning, which have become instrumental in terms of the data analysis, the algorithm development required to sift through large geospatial workloads. Space is very much, the space business is a data business. That is what we've learned through our customers. And the services that play a big role in identifying what those insights and rich information that's coming out of the workloads, that the geospatial workloads, the information that we're pulling down from the skies and serving up into different industry sectors, from agriculture and disaster response and emergency response planning, all the way through to energy consumption, climate change studies, conservation, etc. We also have a very large footprint of customers, and that's part of what we're going to do is a showcase or share what we've learned by working together with them. And then additionally, a huge network of partners. So something that you may be familiar with is Marketplace, AWS Marketplace. So you can build on AWS, but you can also use our channels to distribute. So the ability to spin up an instance or a product or a service that you might have built it in Australia, but to instantaneously have it work or operate for a customer across a different part of the world, that's also entirely possible. And that's something that we are focused on with scaling out companies who build in Australia. So that's a little bit about AWS, what sets us apart. Do we have any other slides on just foundational slides, Jess? We have a global infrastructure, and this is a little bit referring back to what I just said. The ability to port or the ability to instantaneously have your applications and workloads available in different parts of the world using our infrastructure, our back-end backhaul. This is something we can go into depth if it's of interest to any of you. Next slide, please, Jazz. We have an emphasis on green. Amazon has made a pledge as part of many organizations who are becoming more and more aware of climate. So our targets are to get to more green in the cloud by 2040, 10 years ahead of the global climate pledges. And what we've done in working with customers and with our consulting firms, discovered that our infrastructure is a lot more greener. Now, space and sustainability is a topic of its own right, but what we want to do is ensure that if we're building on cloud, we can have that green story to tell alongside of the sustainability initiatives that your mission or your segment may be focused on. That's just something for you to keep in mind. Okay, so this is a hugely complicated slide. We won't go into any detail other than let you know that there is some service that can solve any challenge or opportunity that you identify. It's way too many to go into any level of detail at this stage, but we have solutions from blockchain security solutions all the way through to machine learning, different kinds of compute, basic compute, high performance compute, tons of different ways we can utilize this to help you accelerate your mission or your mission builds. But more on this, again, we'll point to training pathways where you can actually self-pace, educate yourself on many of these. I've talked about the fact that we've learned by serving a lot of customers across the world. They're space customers, but there are fintech customers, universities, telco, media, many customers that we've learned from. We can go to the next slide, please, Jazz. This is just reference point for why we do what we do. Now, the confluence of cloud and space is new. This is being driven by the changes that we've all seen come to play. So miniaturization, the advent of new space, the emerging new space economy driven by private actors. So over the last 18 months, we have stood up an industry business vertical, or a team that is dedicated to looking after space customers. Aerospace and Satellite Solutions is the name of our team. So we are an industry vertical in our own right within AWS. We have a team that is located in Asia, Pacific, EMEA, in the US. Between us, we have about 500 years of domain experience, and that's everything from human spaceflight exploration all the way through to on-orbit operations, ground station experience, satellite engineers. We've stacked the team with a lot of domain experts. We've always had cloud, we've learned in cloud, and the combination of the two is what we see as an asset in when it comes to serving the needs of the new builders in space, the new space economy, where new business models are emerging. And the intersection is where we see opportunity, but it's also what we do in this space that is probably most useful for you to understand. So when it comes to old space, we are reimagining what the old architectures look like and how they can be best optimized for this new world, keeping in mind that a lot of the old world development was, again, high predication on security. So they're very stovepiped, rigid, lack of interoperability. And the new space age is calling for cooperation at many different levels. Data standards have to be correct. Data interoperability is of key interest. The idea that you can spin up a company or a service or a product platform in one nation and sell it across to other regions is also something that a lot of our Australian space builders are keen and interested on. So these are just a few of the things where we found immediate need when it comes to addressing the challenges of our space customers, but we'll go into a little bit more detail as we keep moving through. What we do, can I have the next slide, please, Jazz? I want to spend a little bit of time explaining how we work with customers. There's a number of different ways. We work with government agencies. So what kind of customers we work with? We work with government agencies. We work with private space enterprises. We work with startups, universities, R&D. Our customers come in all shapes and sizes, and they come to us with very interesting use cases. They can be, day and night. One entity is maybe a small LEO satellite constellation that's being launched. How do we run it on cloud? Whereas the other one could be, I am setting up a tsunami warning system. How can I use satellite data or space data to do that? Yet another customer may just be a university that's interested in developing space training skills. So we think about, what does a course curriculum look like? Where do students get hands-on? So there's lots of different areas that we do work in. And I guess the key takeaway from this slide here is you can engage with us in a number of different ways. Perhaps you just want to understand what cloud services can offer. How do they optimize or accelerate your missions? And they do, from a cost perspective, from an innovation perspective, security, resilience, scalability perspective. So these are the simple reasons why you would build a space solution on cloud. So you may want to know more about that. Or it could be that you're already using cloud and you want to develop your competencies further in this area. So we have dedicated teams that are basically teach, enable, support, and can help develop solutions if required. A lot of the times we also engage, we have an Envision engineering team behind us. So if they're complex projects and you're not really certain where to start, we can help with proof of concepts. A lot of the proof of concepts, we can spend some money, we can make some investments. We often have credits. Most times a POC is helpful in understanding whether you want to go a certain direction or you have to pivot after you've done a POC. And we've had lots of companies do lots of POCs and pivot a lot. I'll give you an example. Earlier this week, we had a team from Japan, and they're interested in understanding how do we build a POC for the moon. So it's a company that's looking at lunar space exploration, rovers, how do we build one, and then interesting touchbacks or playbacks to also the the NASA arrangement with Australia. How can I reuse some of what we're doing for the Japan team back in the region? So POCs can be anything. We've worked with Thiru, we've worked with a range of companies. And the idea really is, one, to validate if your business idea or your the commercial model that you're putting together makes sense, is supported by the technical development build, and or it's also just an experience. It's a chance to experience what working with cloud is like if you've never utilized AWS before. Finally, we have a part of our work is also to help grow the industry. So the commercialization aspect is pretty important for us. Commercialization, go-to-market strategies. This is something that we help all of our startups, most of the university spin-outs that are looking at spinning out or have an idea, a product or a service that they want to spin out. The emphasis here is always on, you have a great idea. You may have halfway built a product which is amazing and fabulous, and maybe it's an EO product and it's going to work for the farming industry. But have you thought about the commercial business model? How do you make money with what you're building? It satisfies a need, but how are you going to find a revenue pathway? How are you going to get funded? So earlier this year, AWS did have a space accelerator. We'll be running more of those as time goes by, and we may get very specific, either for a country, or it may be very specific to a sub-vertical. Could be space domain awareness, could be Earth observation. We're still working out where the demand or the latent need is. But this is another thing that's crucial for us, to help you understand or to help you sense check when you're building something, why are you building it? Which customer segment is it going to serve? Will you be able to get funding? Can we connect you to VCs? Can we connect you to test customers? Obviously, you saw the slide, we've got millions of customers across the world. So is there a friendly customer that we can introduce you to who may be willing to experiment or play with your POC? So those are a range of different options in terms of how you engage with us. What do we have next, Jazz? I think I might hand it over to you here, because this is going to go into a little bit more technical detail about how AWS supports the different use cases. Thanks, Jazz.
Thanks, May. So often enough, our conversation with customers will often ask me, or we have to imagine what part of the supply chain, so as you might think of a space organization, a space industry, do they sit in? Are they designing and building satellites? Are they a satellite operator? Or are they simply consuming, satellite data or geospatial data to provide insights to the customers? So we end up breaking down in a lot of my conversations. I ask the customers, what is it that from your business that you are trying to achieve? And then if they say, I want to build a service which helps customers, have space domain awareness, then I'll propose to them that, okay, there are AWS services which can help you build an end-to-end solution. And some of them might be things like building a data pipeline using AWS, our Amazon Ground Station, which allows you to downlink data from your satellite on demand. With all the global presence of AWS, you're able to downlink data anywhere in the world and bring back to your own particular region or your geography, and then pipe that data through using serverless computing, which is AWS Lambda, to AWS SageMaker, which allows you to build and train your machine learning models and then deploy them to production so that you can run inference against them as well, and to eventually build an insight, whether it's in agriculture, defense, water monitoring, or bushfire monitoring, and deliver that insight to your end customer at the speed and scale at which you need. Often enough, we will tell our customers, and we hear that as well, space solutions are replicable around the globe, and they can be redeployed. So somebody who's monitoring fires in Australia could be able to deploy the same solution in California, in the US, and be able to monitor fires there as well. So this diagram simply goes on to talk about that AWS has the capability and the services to support customers in each of these segments. I'll hand it back to you to talk a little bit more about our customers, Manny.
So we have lots of different customers, and they all have very different use cases. We've chosen a select few, just to give you a taste of who's doing what and how. NASA JPL is one of AWS's earliest customers. They've been with us for the last 10 years and counting. We have lots of different missions that we support them with. Perseverance, which is the latest one, because Curiosity is a couple of years old now. Perseverance, most of the data that's all of the data for Perseverance, the little rover landing on the terrain, rolling around, that information is hosted and processed on AWS, helping scientists and NASA explorers work out what they need to do as far as the next stage of the mission planning is concerned. So that's one. The second one is Fireball International. Fireball International is actually an Australian company. I think they may have recently been renamed Exi. So they're going through a branding process. But we worked with Fireball to essentially build a solution where within 3 minutes of smoke detection, they're able to understand if there's a smoke signal, if there's a fire coming, use ML models, IoT, comms back to fire departments, emergency rescue services, basically the community folks who need to evacuate people and livestock. Super cool example of one of the ways in which we're able to utilize Earth and space data, because there's ground sensors involved here, as well as space satellite imagery. And one of the things that we'll talk about later is how you can build solutions around disaster response and recovery, which Amazon will not only support you with the technical infrastructure build, etc., but also in the communities where there is an emergency or a disaster, we've got other services, other teams that will come in, physically help, whether it's field relief or suspending our billing for the period that there is an outbreak of fire, flood, whatever in the community. We'll talk a little bit about that later, but this is something that we're particularly passionate about, using Earth data for good, so technology for good. And we've got quite a few initiatives around this, particularly around flooding, fire, earthquakes. Many of the world's regions are going through strife. I mean, we heard earlier this year about Greece and Turkey wildfires. There seems to be a fire everywhere. We look every time I open the newspapers. But as climate change worsens, we're only expecting to see more and more natural disasters. So early warning systems are essential. We believe that we have a duty to focus on this. So we have a very specific focus on this. And if there's anyone interested or building solutions, particularly around disaster response, please reach out to us, because there's a lot we can do to help you. Okay, next slide, please, Jazz. So we have NASA, Fireball, Capella Space is another really interesting customer. Now, they're a US-based company, and they acquire and process a lot of SAR data, SAR intel. They run entirely on AWS infrastructure, so it's a wholly cloud-based solution. And they have been able to bypass traditional satellite image providers with speed, bypass them for speed, costed innovation, and offer their end customers a product and service which is twice as fast, if not faster, and able to be very specific to areas that they're areas of interest that they can deliver at cost. So that's another geospatial workload use case, as well as using our ground station. So it's the entire value chain that I think there's reference architecture you're going to share later, Jazz, right? Around,
yep,
the image acquisition, processing, and then readiness with insights. That's another really great example. These are super high level example, guys. So what we want to do is we just want to give you a flavor, and then we'll go into looking at what a reference architecture for one or two of these actually look like. Next slide, please, Jazz. Black Sky is another very similar to Capella in that they've built natively on cloud. Again, traditional command control systems are being replaced by virtualized mission operations. We're doing that for Mission Control Center in Australia with Sabre Astronautics. This is an American example of yet another customer that is utilizing cloud to derive benefits for their end customers. So it's not just addressing some of the typical space challenges, space data, Earth data challenges in terms of the size of the workloads. These are petabyte size scale data that is being processed relatively quickly, like very quickly, in order to derive insights. And those insights can be real time, again, like back to the Fireball example of delivering insights so rapidly that instantaneous action has to happen. Or they could be data that is crunched over a 10-year time series. And I think that's the next example, Jazz. Is it about DigitalEarth Africa? I'm getting ahead of myself, but We've got yet another NASA example. Okay, so the NASA is just a great customer because they've got so many different missions. And if the first one, Curiosity, was about streaming images, Perseverance is processing data for the rover, the Asteria satellite, that's literally searching for exoplanets. So lots of different angles from a civil space perspective of supporting space agencies. And we're starting to do similar work with other agencies, other space agencies across the world. Again, because the rise of private actors or the private subcontractors who are supporting space agencies, national space agencies, remove the burden of some of the work that they've been, because they've been typically buying, building, developing their own solutions. Now they can literally go out to the best in market and say, I need this mission, this is the brief that I have. And then it allows us, and it also allows the new builders coming up in the space economy to be a part of that conversation. Next slide, please, Jazz. Okay, disaster response, building geospatial. We thought this might be really interesting simply because Australia has got, the Australian Space Agency has a huge emphasis on the EO roadmap. And of course, we're a nation that's fragile when it comes to our ecosystem. So we're very interested in understanding who may be interested in this area and really apply emphasis on helping those who want to build solutions, particularly around disaster response and recovery. Next slide, Jazz. So, oh, we didn't have a slide. Oh, I'm so sorry. Okay. I guess what I wanted to share, which I may have already done, so sorry for repeating, it's an area of interest for us simply because we want to make sure we recognize that solutions in this area are few and far between. And we talked about several of the issues that we mentioned much earlier: data interoperability, the availability of data, not data, I guess insights, the availability of analysis-ready data, which then is processed through systems fast enough to derive intelligence, whether it's fire or flood. We want to do more around that. So the kind of support that we offer to builders who are particularly focused in this area is credits, technical support, and in the instance where there is unfortunately an occurrence or disaster, AWS will jump in. We have other solutions like Direct Connect. We can spin up an emergency response number, for instance. So when traditional comms fall by the wayside in the event of a disaster, there's still reliance on our backend infrastructure or backhaul infrastructure. And or we have portable devices, and Jazz will talk about snow cones and other such products where it's literally possible for us to set up comms bridges. So it's either for the emergency response disaster team that's coordinating rescue efforts, or can be actually for residents trapped in a flood, fire. So we can do things like that. And then in addition to all of that, two other things. We have a team of people, we have lots of volunteers within AWS who are willing to, depending on the country, go out to the field and support in times of crisis. And then we also have a bucket of funding that's set aside specifically for communities going through strife. So whether it's COVID or the Greek wildfires, for instance, we were able to put aside money just to support communities get through that particular process, particular disaster. So there's benefits to, it's not just about building a product or a service that can support communities when they go through strife, but it's also ancillary things that we can do because we believe we have a responsibility to the communities that we serve. That's all I had on that one. Jazz, do you want to do open data?
Yep, absolutely. So as I think it continues the thread about sustainability and how AWS is providing access to the larger community, whether it's for disasters or for research in general as well. And that's how the registry of open data came to be, that we recognized a need from our customers across the globe that data by itself needs to be organized. It needs to be made available error-free and in a format that is accessible and is, I'll use the word analysis ready for anybody to come and consume, whether it's a student, a researcher, a PhD, or an enterprise trying to do their own research as well to advance. And this quote is representative of that. Cleaning the data most often is some of the most taxing part as well. And this is where the mission of open data starts as well. So open data can be accessed at OpenData.aws, and effectively it is the initiative which is sharing of data in the cloud for users, enabling them to spend more time on analysis rather than actually acquiring the data itself. Some of the benefits we've again already observed and continue to observe is that we have a global community of users who come and access the data. Some of the most common, some of the most recent data sets which have been uploaded are data around the vaccine and the impact of COVID as well, which has been made public from institutions like Johns Hopkins and others. There's massive amounts of Earth observation data as well from organizations like USGS and others. You can find satellite imagery from Sentinel, Landsat, satellites and others, again, available all for free. And as this data comes available, not only is the raw data available to the users, but along with that, the tools and the services necessary to access that as well. What we have observed is that this is helping customers increase their pace of research because, again, they don't have to worry about the data being analysis ready, and also lowers the cost of research for themselves. And considering that they can plug together their services very, very quickly to get an outcome rather than worry about standing up infrastructure, purchasing servers or maintaining them as well, and then installing the software on top of them and then doing the research. So that's one huge benefit. One example I thought of was just how cloud optimized geotips come together. They take a lot of effort and compute power to be prepared. So what if, as a customer, as a consumer today, you had access to cloud optimized geotips straight away to consume? Wouldn't you be able to focus on building value for your customers rather than actually creating geotips themselves? This is just an example. Furthermore, we observed that data again has persistence in terms of being able to share and make available to others. As you create and as customers create more and more data products, data exchange was necessary as well because it allowed data providers to reach millions of users around the globe, distribute the data in more secure ways as well, and compliant across into the geography you're located in, and not worry about maintaining the data, the storage required underneath, the delivery of that to different regions as well, and the entire bill, the billing process as well. From a subscriber's perspective as well, they were able to access data in different formats when it got published, got notified, access this new data automatically, and also being able to find diverse data. As I said, you can find data sets on open data ranging from research data sets, from COVID, from healthcare, all the way to Earth observation data sets. So I encourage everybody to continue to go and have a look. One example, again, I spoke about is Landsat 8, which lives on AWS. It already hosts more than 200 plus terabytes of data, which is available today to everybody for free. So please continue to go and have a look. What you can also do, and what we see today, is being able to avoid the traditional approach of bringing the data to the computing resources. Typically, you'll observe, researchers will have a cluster of computers or servers where they're going to run the data, and then the data has to be downloaded and made available to those compute resources. However, when you're accessing the same data in a cloud, the approach you would take is that that data will be placed in a service like Amazon S3, which is a simple storage service, allows you to store massive amounts of data in one place, and then you can simply run analytics on it. Whether you want to run quick analytics analysis or using ad hoc SQL queries with Amazon Athena, or you want to run compute, you want to run up a server to install your own software and run libraries using Amazon EC2, or you want to run an EMR cluster again to analyze the data. Some of the customers, some of the examples which come out of this is again the imagery available from OneSoil, which have run boundary detection for more than 39 million fields in Europe and 29 million fields in the US. And this is all done through an automated process. And the comparison they draw that if this had to be done manually, it would have taken them 49 years to do it. But that automation allowed them to do field monitoring at scale. And I'm sure a lot of you would appreciate that, this analysis rate of the data can then be taken and used to run additional algorithms on top or create new models, new machining models, and new insights for customers as well. Another example is the Blue Dot Observatory, which has been using Sentinel-2 satellite data, which is again also available on Open Data Registry, to monitor water bodies around the world. And again, the quote or the experience they've had is that before, to process 1 month worth of data, which is about 700,000 bodies of water, it would take them a longer period of time. And now, not only time and also money, but now it's possible for them to set up world-scale systems on a very, very cheap shoestring budget. Just in one example. The last example I'll probably give you is DigitalEarth Africa, which is also made available and openly accessible data, continental scale data for the entire AfriGeo community to be able to address their needs and challenges and prioritize them for the African continent. So this has also come about due to the data being made freely available on Open Data Registry. Again, I invite everybody to come have a look at digitalearthafrica.org to have a look at what kind of observations they've been making across the African continent as well, and how it's been helping communities there locally. I wanted to slide in a little bit of a common interface of what customers see and what you all might see as well as a kind of repeatable pattern where your data comes from different sources and how you can fuse the data together. And we see in the industry data coming from drones, planes, assets as well, or commercial Earth observation data coming from satellites, from different sources, from different types of satellite imagery data as well, whether it's SAR imagery or other optical imagery, and then other raster data being made available as well. But the intent to bring all these interfaces together in one place so you can run machine learning against them, that this is where cloud really truly provides its value. And then any of the insights which come out of that can be made available to a number of platforms, whether it's a GIS platform which is cloud-based, whether it's a mobile application being given out to farmers, whether it's a desktop portal like QGIS or ArcGIS, which is being used, or you just need API access to the data so you can run additional machine learning computation on it using R or Python or any of the scripting language you might be working on today. That ends, that's the finish off. That's all I'll talk about from the Open Data Registry. And we'll move on to the AWS Feature. Manny, I'll hand you back to you.
Okay, thanks, Des. One thing I wanted to add on the Open Data Registry, if you believe you have data sets that is important and vital for other researchers to access, please let us know. We can host that for free. We do have a qualification process, so we want to make sure we're not repeating or putting in data that's already accessible. But by all means, Australia as a region or any southern hemisphere is something, because there's a high emphasis on existing satellites which seem to predominantly serve US, Europe more so than the Asia Pacific region. We are also interested in understanding what else should be made available to the research community, to the innovation community, to the builder community. We've had startups in Australia who have built an entire business model, a space business model product, based on utilizing open data, not just from AWS, but from all the other public satellite information that is available. Okay, AWS Feature. This bit is important only because a lot of the solutions that you saw being built by customers, they're relatively cheap. And there's over 100 different products that you can actually start building with if you wanted to experiment what cloud looks like. So several of our startup companies typically spend $100 to $200 as far as infrastructure costs are concerned as they start building out. When they turn into unicorns, that's where we see benefits. So if you're a startup looking at building a space product or a solution, please think about cloud, not just from a cost and innovation perspective, but also for your end user. So many of the larger space providers have very expensive monolithic products, whereas with cloud, you pass on the benefits. Obviously, it's dependent on your commercial business model, but very often we see that the ones who are winning the space race today are the new space companies who have a very thin sort of infrastructure cost, which they can then pass on, and they're simply deriving benefits out of the insights that they're sharing. So we can share a little bit more detail, Jazz. Is there any other slides on this, or we can leave them with links to, how to access and set up an account, but it's pretty simple. Next slide, please, Jazz. Do you want to talk a little bit about training? Because I guess there's a business component and then there's a technical component. What does this slide look like? Do we have any other slides, or is it just, okay, you can talk about this because this is one of your key missions.
So again, we've observed from our conversation to customers that we are facing a cloud skills gap. And as Patty's been talking about, how easy it is to not only innovate, but to build rapidly solutions for your customers using cloud services. We've also observed that a lot of organizations are reporting that they don't have the necessary skills to build. This is essentially my job as a solution architect, where I get to educate and inform customers how they can plug in different services to build their end-to-end solutions. But a goal is also to inform them they can upskill themselves, because we have seen as you achieve your cloud goals with training, whether it's digital training, classroom-based training, or hands-on labs themselves, or you want to go ahead and be certified in a particular specialty yourself, whether it's security or machine learning, that your total cost of hosting your infrastructure comes down. So there's cost savings. You build operational resiliency because your solutions can be completely automated. They can respond and be scalable based on different demand. The staff themselves are more productive because they're not only learning new things, but are also innovating themselves. And the business themselves sees an uptake in agility. They're able to respond and pivot to changes in the industry, changes in demand themselves as well. So the key takeaway I wanted to give away is that there are tons of courses available to everybody online. So you don't have to spend any money. There's free courses which you can go have a look at based on demand, also based on domain. So go online to training on AWS and have a look at what you are passionate about. And the portal, the online portal, will explain to you how what your learning path may look like. So there's over 300 training courses online, which are which can be as specific up to your role or level of expertise. So from all the way from the basics of a beginner to more advanced courses, and they're convenient because they're available to you anywhere you are in different languages, and you can do them at your own pace. So please do encourage you to learn more about how you can use different services to build your own solutions. I'll hand back to you, Manny, from a commercial aspect as well of how training is beneficial.
The only thing that I really want to add here is we have a focus on diversity and inclusion. In fact, a lot of the training courses were made free during the COVID period, when we realized that it was going to be, we were going to face skills. And it's not just AWS as in for ourselves, for our own pipeline of talent, but it's for the industry as a whole. And one of the things we've done is we've created programs. So aside from these, what Jazz has shared, there's also a program called She Dares that's focused on women who want to up their cloud skills, and it helps them get into any other industry that that helps them by in possession of cloud or digital skills. We also have several other training programs, and we're starting early. It's not just professionals in the space sector. We are now looking at increasing our STEM pipeline with kids as young as 14. We've started a mission discovery program for them, and we are going all the way through to university. We need more skills. The world needs more digital skills, and space is becoming so interdisciplinary in the sense of a lot of people have very deep domain expertise in one area, but the commercial business models that are being built, much like data fusion, you need to be an expert in agronomy or energy, and then on top of that be an engineer, have cloud skills. And the only way we can build amazing new products and solutions, or find solutions to challenges which we've never tackled before, is combinatorial skills. And that comes, and so again, that really comes, it's a team effort. So we're super happy to share what we can in terms of helping you learn, support where we can, but also encouraging you to pick up as many skills as you can at your own pace, in your own time, at no cost. Okay, this is specifically designed for startups. We do have, and Jazz, we've got, we should probably wrap this up quickly so we don't make sure we spend some time to answer Q&A. We have a couple of different programs for startups specifically. AWS Activate, if you have a look at that on our website, we have credits, technical support, and a bunch of other things that we can help if you're starting to, if you have ideas or plans to build out your own startup. We do that for small startups. We do that for startups that are part of an accelerator or an incubation program. So there's differences, but we can work through those, or you can have a look at that on our website. Next slide, Jazz. Do we have any more?
No, we're happy to take their questions at this point. And there is more reference material here, which I will include as a takeaway from a reference perspective. Yeah, I'm happy to take on questions now.
Let's have questions. Let's make this interactive. If Asha, you wouldn't mind helping us.
Yeah, absolutely. So would encourage people, and look, huge thank you. I've been madly scrambling so many different notes, and it's just phenomenal, I guess, the generosity and spirit in which we're all operating to make this world, I guess, a better place. That might see a little bit of a lofty ambition, but there's so many incredible and rich insights that we can get that can really help us protect the Earth. I was actually thinking about, like, one of the things that when with the space sector, and they're saying we're going to have 30,000 jobs by 2030, which would see an increase of an additional 20,000. And as you said, that skills shortage is so critical now. Where do you sort of see some of those opportunities for people to grow, and where some of those jobs may come from?
So it's a range of different things, Asha. For me personally, sometimes we seem to, so different environments have different gaps. Some cases we are idea heavy, have great ideas, no technical skills. And in that instance, there's a lot of investment that's required to, because it's not just about designing a product for that period in time. You actually need to develop an organization. And what we're discovering is a startup with a great founder, visionary founder, and maybe one CTO, they have to go on the journey. It's as much as building your talent up and your skills up as it is doing all the other stuff, finding customers, finding VCs, etc. Where is it going to come from? It's because the value chain for space is so big, the opportunities are enormous. For me personally, I think Earth observation, geospatial workload analysis is massive. We can spend time on launch sites and standing up satellites and rockets. Those are going to be, I don't want to say niche because it's happening far more frequently than we ever envisioned possible. But I think the bulk of the work, for me, that what I said earlier about space is very much a data game, centers around data. So if you have the skills, analytical skills, the ability to make sense out of a dross of information and drive that to an outcome, either to save the climate, a disaster response scenario, or add value to insurance companies after the fact, after a disaster, for instance. Or even, I had a prospective customer yesterday that I was talking to. They're tracking population movement in conflict zones. They're tracking food security for the population that's moving from one region to another. They don't have military, they can't take military help or defense intelligence. The word intelligence cannot be used when you're working with a not-profit, for instance. So there's so many scenarios that we haven't actually thought about, that satellite imagery and the analytics that we're running can now change how we do business or how we support certain sectors of society, which we previously may have failed or not been able to. So I think as long as you have a passion and you know kind of where your gap is, there are now tools and resources from many different parts of the industry. There's a lot of different organizations that are putting forward material and tools and support to help. A hard question to answer, so I feel like I'm not completely answering it, but let me know.
No, and look, I don't think there's any particular, it's everyone's perspective. So it's great. I know that you're a really passionate sort of advocate and supporter for the space sector as well. So thank you. We have a question, it might be more for Jazz, from Daniel. So, and I know that Daniel's got a phenomenal community that he's built around data science with Daniel. So I'm hoping he'll share all this with his network as well. So he says, you say people need to develop cloud skills. So I'm just trying to read it all out. So it's quite a broad statement, but there one sort of key skill or one service where you think that people need to be familiar with for space data. Where would you recommend that they start, and maybe what does that journey look like?
I would say there are, as the space industry has come along, it doesn't quite adhere to one particular standard. So there are many standards of Earth observation data which I observe being used across the globe. However, if a student today was to begin their journey or was to start thinking about skills they need to develop, I would ask them to develop skills on, as Manny said, disseminating Earth observation. There's definitely a component of machine learning involved in there, because we are receiving much more data today than we ever were, and satellites are making large volumes of very high fidelity and very rich data available to us. And people manually, we cannot go look through that. So we need machine learning capabilities to screen that data. A lot of that machine learning capability is also being put into orbit now. So if a sensor collects some data, that the machine learning model automatically right away disseminates it to go, is this good data, or is this just, there's too much cloud cover, for example. There's no point in me sending this down back to Earth, things like that. So machine learning and Earth observation data analysis. What does that journey look like? I would, again, as a builder, my go-to would be, I'm going to have a look at what are all the resources available online. What are, again, Open Data Registry, plug for Open Data Registry here to go have a look, because not only do you get access to satellite imagery right away, you get access to different types of satellite imagery. So what does SAR data look like? What do I have to do to make an analysis ready? What does analysis ready data look like? What are the tools being used in industry today? Which ones are slower? Can I leverage containers to do that as well? So my goal would be to experiment or play with the data available to you today from different sources. That's what that would start like. I would have to look at my university to see what courses they offer. I don't think they offer anything around satellite or Earth observation data, sadly, yet. So that journey is not as clear as it might be. Manny, do you want to comment on the educational journey for students?
No, I think organizations, universities, UNSW, RMIT, Curtin University, everyone's starting to recognize students or wannabe entrepreneurs need more than just conceptual knowledge. So I liked what Jazz said about getting your hands dirty, start experimenting. There's a lot of material already out on the web. It's called the new space economy because every individual has now the power to create something. Literally, I've never had access to satellite comms before. Through Ground Station I can. So the first thing that I would do is jump on AWS Ground Station, see what satellite you can connect to, what information can you pull down, and what business model can you make with it. Those are simple experiments. But I think there's space is it's both wide and deep. So I think if you have a sense of where you want to go, you can find mentors. That's the other thing I would encourage you to do. Talk to other people in the sector who can help you understand what their path to their journey look like, and you can learn off that. But your sense of gut, your sense of instinctive, what your gut's telling you should sort of helpfully guide you towards what you're looking for.
Excellent. I don't know if we've got time for, sorry, it's just a comment back from Daniel again. So thanks for those insights. We'll definitely be looking into the data and thinking about what can be done with it, which I think is a great segue in terms of just really encouraging people to, I guess, get involved with things like your various hackathons and datathons. And we had the NASA Space Apps Challenge a couple of weeks ago. So I know there was quite a few of us that were over at UWA working on it, and it was great to actually participate. So look, a huge thank you for your time and sharing so much wisdom today. Really informative and so much content. I will make sure that we send out a proper wrap up to everyone with links to all the various things, because there's just, I think there's such a there's so many different things that are available, and people get a little bit lost in terms of trying to navigate it all. But I think that this starts to spark that sense of curiosity, and awareness of the opportunities that are actually there. So, as I said, thank you so much. Really appreciate it on behalf of the Australian Space Data Analysis Facility community, and looking forward to sharing this more broadly as well. So thank you for those that have joined us online, and also we will continue to promote and share different opportunities that people have to get involved.
Pleasure to be here. Thank you so much, Asha, for hosting us.
Thank you so much again.
Brilliant. Thank you.